Welcome to Category Visionaries, the show dedicated to exploring exciting visions for the future from the founders who are on the front lines building it. In each episode, we'll speak with a visionary founder who's building a new category or reimagining an existing one. We'll learn about the problem they solve, how their technology works, and unpack their vision for the future. I'm your host, Brett Stapper, CEO of Frontlines Media. Now let's dive right into today's episode. Hey everyone, and welcome back to Category Visionaries. Today we're speaking with Brian Manning, CEO and co-founder of Xona Space, a space tech company that's raised over $40 million in funding. Brian, what's up, man?
Hey, Brett. Nice to be here.
Excited to have you. Let's go ahead and jump right in. So talk to us about what the company does, and I have a long list of questions that'll follow.
Sure. Yeah, so what we're doing at Xona is building basically a new generation of GPS. And so our company came from a mixture, I guess, myself, I worked at SpaceX, but a lot of the company really came from our CTO, Tyler. And Tyler did his PhD at the Stanford GPS lab back in the 2015-16 timeframe. And this was right around the time when Starlink was, becoming a little bit more than an idea, and the world was starting to realize that, hey, this idea of like a large number of small satellites could really be something interesting. And Tyler, being in the GPS lab, chose to do his PhD and looking at that architecture in this new space world. Could that be used to make a real impact in the navigation world, as opposed to, communications or Earth observation that a lot of other people had been looking at? And, the conclusion he came to it was definitely yes, that, a architecture with a bunch of small satellites in low Earth orbit, much closer to Earth, could provide far better GPS capabilities than exist out there today. But, like most people do, he finished his PhD and he put it on the shelf and went off to work. And Tyler went to work at Ford in their navigation departments out in their autonomous division here in California. And a lot of what he was responsible for there was researching what systems and technologies can very reliably keep self-driving cars and hands-free capabilities. How do you keep these vehicles centered in their lane, but how do you do it in a manner that works in any environment, even when the car is covered in snow or rain or fog or dust or mosquitoes or whatever else is out there? And how do you make this really affordable and scalable? And what he was finding was that GPS is like perfect complementary system to LiDAR and vision and all these other systems, that those systems work really well in certain environments, largely sunny weather in big cities. But when you start to get out of those environments, it's not that they don't work at all. It's just that the safety is degraded. And so you need a complementary system. And GPS is most at home if you're out in the middle of nowhere, out in the open, or you have a clear view of the sky. But to really provide safety to those vehicles, you need reliable centimeter accuracy, and GPS can only provide you, just like kind of reliable meters effectively. So that was when you started putting all these pieces together, saying, okay, well, if we could build the system with all these small satellites, we could actually start to provide those reliable centimeters that cars need. And as we started looking around, we started realizing that there's, it's not just cars that need better safety, that 7 billion other devices around the planet that use GPS today also. And there's just GPS is this monster that powers everything from financial grids to power grids, even our financial, our entire financial system depends on it. Not to mention transportation, logistics, defense, that there's so many things that rely on GPS, and all of them in general are interested and would like to have better performance. There's just really not much out there that's available to them. So we started putting all the pieces together and building up the system ourselves, and said, okay, if nothing else exists, why can't we do it? And, that was about 5 years ago. And yeah, so we've been off and rolling ever since.
I was reading a little bit about the history of GPS before we jumped on the call. It looks like it started kind of in the 1950s, early 1950s. Correct me if I'm wrong there. What have been the big evolutions in GPS technology, or have there not been any? And that's the fundamental problem here.
Yeah, so if you broaden the scope of that a little bit to say, what has been the evolution of navigation technologies, there's actually something we call Reed's Law. So Tyler's Dr. Tyler Reed. And similar to what you see with Moore's Law in processing power, how it continuously increases, there's law in navigation, where the accuracy of navigation capabilities, I think it gets 10x better every 30 years, I think was the rule. So if you go back, once upon a time, it was celestial based. And so if you're sailing across the sea, you can use the stars and you can figure out where you are to within several kilometers or so. If you move forward into, once radio transmitters start to be becoming useful, there were these long range radio broadcasts where you could locate where you were let's say a single digit kilometers or hundreds of meters or so. The next stage beyond that is when satellites started to come out. And so there actually was a precursor to GPS called transit. And transit could get down into the tens of meters accuracy. And then the history of GPS, you mentioned there, GPS fired up. It was kind of in the 60s. And it really was born right after things like the Cuban Missile Crisis and in the middle of the Cold War, where the US identified a need to be able to strategically place things that fly through the air and potentially make big holes in the ground and put those anywhere on the planet with accuracy that is better than tens of meters, that you're into the single digit meters, and do it for high speed devices. And so they contracted the Aerospace Corp. There's a famous report called the Nakamura or Woodford Nakamura report, where they walked through and said, what are the technologies we have available? How do we solve this problem? Hey, there's this thing that's called a satellite. This is becoming pretty cool. And this is shortly after Sputnik and whatnot was happening also. And the very clear identification coming out of that report is the GPS, as it stands today, that architecture is essentially the perfect architecture to solve that specific problem. And as you kind of mentioned, so going forward, how has that evolved? The architecture of GPS really hasn't changed that much in the past half century. And that is part of the challenge, that the use cases have evolved from airplanes and missiles. It has evolved incredibly rapidly into farming, phones, trains, planes, ships, trucks, cars, everything else. And all of these new applications that use GPS, they operate in very different environments. They have different requirements. And so as we built the company, one of the first things was kind of almost redoing that Woodford Nakamura study and saying, what are the needs of devices in 2025 and 2020, and when we did it, and how do we build a system that is optimized specifically for them? And what you end up with is something that has certainly some similarities to GPS, but it also has some significant differences. And the low Earth orbit satellites, the small sat system that we're building, is really the first of a new generation that's optimized and designed for navigational challenges and needs of current technology.
Is it going to make GPS as we know it then obsolete?
I mean, anyone building a system that says, hey, we're just going to go throw something up, and it probably doesn't fully, appreciate the monster that GPS is. The way that we've designed the system is very much to be a complement to GPS, at least in our short term. Over the longer term, it is something that the capabilities start to grow where it can operate fully independently and in kind of parallel to GPS. But most of the chipset companies that we're working with, the receiver companies, are building devices that can pick up both us and GPS. And we think that is the correct approach here. And one of the things that we've, very deliberately done is we've designed our system to be compatible with most GPS receivers, even without making any hardware changes. And that's super key that, there's 2 billion or so new GPS devices sold every year. And if you try and go to the customers that are buying those devices and say, hey, I've got this great service, all you need to do is add a new antenna, add a new chipset, et cetera, it's a pretty tough sell. But if you go to them and say, I've got this great capability, you need to reflash or, update software or firmware, it's a really different story. So I think in the short term foreseeable future, if we were the only system up there, we would have the same problem GPS has today, would be a single point of failure for the entire world. And so we see ourselves as filling in gaps that exist, but not necessarily, the one ring to rule them all necessarily.
This show is brought to you by Frontlines Media, a podcast production studio that helps B2B founders launch, manage, and grow their own podcast. Now, if you're a founder, you may be thinking, I don't have time to host a podcast. I've got a company to build. Well, that's exactly what we built our service to do. You show up and host, and we handle literally everything else. To set up a call to discuss launching your own podcast, visit frontlines.io/podcast. Now, back to today's episode.
Let's go back a bit to 2019, the early days of the company. When it comes to technology like this, where do you begin? If you're building cybersecurity software, if you're building just any category of software tool, I know exactly where to begin. I know exactly what to do. Where do you begin here?
Yeah, that's a good question. I always remember the very first time I pitched this was at a accelerator event with Seraphim over in London. And I got done with the pitch, and a gentleman in the front row, I think he was at Air Force, that raised his hand. He just kind of looked at me. He's like, so you're going to build a new GPS? Like, how are you going to do that? And it's kind of like, well, I guess the pitch wasn't that good. Like, we're going to do it one step at a time. And it's very much the way that we've approached it. GPS, most people think of it as a satellite system, and even the satellites get the fame and the glory, but it is a full three-legged of the stool. There's the satellites, there's the ground operations segment, and then there's the user equipment also. And so we started, our core competency was largely focused around the technology that lives on board the satellites, and how do we shrink down the technology on board to the point where it's affordable from both size, weight, power, but also a cost standpoint to go on a small satellite. And found that, okay, there's ways that we can prove that core capability works in the lab. The next step is we can prove that that core capability works here on the ground, and we can transmit and receive signals on the ground before we're in space. And doing some of that work was enough to get us kind of to the next funding round and say, okay, well, let's go prove that it works in space at a prototype level. And as we keep building, we keep building out the capabilities around it and start building up the ground segment. You start building up the user segments. And like I said, it's one step at a time. You solve one problem, then you solve the next. And if you solve enough of them, you're successful.
Let's talk about maybe a comparison to just timeframes here. So in 2019, when you're talking about space tech, did a lot of investors just think you were insane? And the reason I ask it in that way is because it seems like right now, every VC, every investor I talk to, everyone's talking about space and space tech and hardware and hard tech. Like, have you seen just a massive shift there?
People will be thinking I'm crazy long after I think Xona exists, probably, and they thought I was nuts before that, probably too. So yeah, anytime that you're pitching an idea that says, the final version of this system involves several hundred satellites, you get some funny looks. But there was I don't remember who it was, but I remember one investor, somebody asked him on a panel once, like, what do you think about hard tech, really high CapEx investments? Like, are you concerned about those? Are you scared about those? And his response was great. I think it was actually Shaheen from Lux that made the comment. It was like, just bring me a good business. Like, I would rather see a good business. And like, if there's a good business that like you validated the business is there and it's high CapEx to get there, but it's clear that, there's the high revenue and the high reward on the backside, I'm way more interested in that than a bad business that is low CapEx. And he worded it much more eloquently than I did, but it just made sense that if what you're building is important enough and valuable enough and has enough demand and interest for it, the high CapEx side is overcomable. And that's, I think, partly what, the space necessarily and high CapEx, they tend to be pretty well tied. I think SpaceX and what they've been doing with Starlink and with Starship obviously brings a lot of excitement and visibility into the space world. And it should. I mean, space is an exciting place, partly because space is just a geographical location, but the uniqueness of it is that the superpower of space is scalability that literally covers the entire world. Where, what can you do with tens or hundreds of telephone poles or ground transmitters? You maybe get the Bay Area at best case. So it is a real reason to be excited in space, especially when you're looking at things that have, global impact and can make that big of a just impact in the world.
When it comes to the business case, then, are you primarily selling it to the government? Are you selling it to the private sector? Like, what does the current focus look like?
Yeah, our current focus is, I guess, mirrors pretty well the users of GPS today. And so GPS, despite being a government-owned, government-operated system that's built for the government, by the government, primarily for government defense users, the majority of the users are commercial. And that if you look at the number of cell phones, the number of cars, the number of IoT devices, the number of tractors and farm equipment and ships and planes and whatnot that use GPS, it massively outnumbers the number of folks on the DoD side. And all of those users have different needs, different threats, different challenges. But in general, you can kind of boil it down to, on both the government side and the commercial side, they all need assured PNT. They need to have confidence in knowing where they're at. And the challenges that they run into with GPS today tend to sit in the bucket of, we call it precision, power, and protection. That, the users either need higher levels of accuracy, whether it's going, for cars, GPS can kind of tell you what road you're on. But, cars today, if you're going to take your hands off the wheel, just knowing what road you're on isn't good enough. You really need to know what side of the road you're on, and you really want to know if you're still in your lane or not. The power side is that users back in the 60s, a missile has a wide open view of the sky, so does a plane. In the current world, there's the operating environments. You're underneath trees, you're in orchards, farmers are inside of polytunnels. You might even be inside buildings is where a lot of people want it to operate. So just having a much more powerful signal that can reach other places solves a lot of challenges for a lot of users. And then the protection side, and going back to the car, if you're going to go take your hands off the wheel, you want to have 100% certainty that whatever signals are guiding that vehicle are genuine. And so those are the three main areas that our system, I guess, shines, and then some of the gaps that we're targeted to fill in. And originally, we were designing that and building that to solve challenges in the commercial world. But as we've been talking to the government users, realizing that the threats on power, for example, that they need is more because of jamming and intentional interference as opposed to orchards and trees blocking the signal. But the solution sets have oftentimes similar solutions that can meet them.
I see one recent government contract you won came in February from the Air Force. What was that like to win that contract? And maybe just for those listening in, like take us behind the scenes. Like what happened to get that announcement to go out into the world?
Yeah, we've been very fortunate to have some great partners on, Space Force, Air Force, supporting us to help bring our system into becoming a reality. That was one of the first contracts that was kind of moving beyond the SBIR world into a multi-million-dollar contract. You have to give credit to, our team being able to hunker down and being able to find the right folks within the government that have the needs, that have the interest, and getting the right proposals and the right capabilities in front of them. And then similarly, the technical team being able to actually get us to a point where we have enough exciting capabilities to show the government that they're willing to invest in us to help bring it to the next level. And so that contract specifically, we partnered with quite a few user equipment manufacturers, which was great to have on board also. And so what that contract is doing is really demonstrating that we can put our service into these receivers and chipsets and GPS equipment that is effectively just coming off the shelf. And for the first time ever, you can get secure, high performance GPS alternative capability in an off the shelf device. And that's something that, again, is very exciting in the commercial world, but something that obviously has a lot of value into the Air Force and other folks around the DoD as well.
This show is brought to you by the Global Talent Co., a marketing leader's best friend in these times of budget cuts and efficient growth. We help marketing leaders find, hire, vet, and manage amazing marketing talent for 50 to 70% less than their US and European counterparts. To book a free consultation, visit globaltalent.co.
What about the marketing side of things? So what does the marketing strategy look like today? And how do you anticipate that marketing strategy is going to evolve over the next, maybe let's say 12 to 24 months?
Yeah, that's a great question. We're continuing to, our founding team was a bunch of engineers, so we're still learning the whole marketing side of things. I think what we've generally found is that there are just so many use cases and so many potential applications that our pipeline of interest and demand is kind of so huge that we can't actually pursue all of it. And so we've had to really focus on what are the core markets, who's going to adopt this in the early stages of the system, who's going to be able to accept the capabilities as they build up, who's going to be there that's interested in using this, being the first ones out of the gate. And so we've limited our focus back to several of the core markets. And for others, we're still engaged, we're still doing testing and sharing results, but it's been more of a laser focus in on what are the core target markets as opposed to just going very broad. And then from there, you really need to understand what the customers in those markets need and care about. Because if you look at GPS supports everything from dog collars to F-22s, the, interests of the customer who is building the dog collar and the challenges that they're facing are probably incredibly different than the interests and the needs of the customer that is building the 787 or the F-22 or something on the other end. And so it's really, those are things that you don't learn sitting behind a desk either. So part of the marketing strategy is get out from behind the desk and go talk to your customers and understand what they need and understand what they want and make sure that that input is making it back into our system to give them something that actually solves their problems.
When we just look at your big picture vision here, so I don't know how far out we need to go, but maybe 10 years, 20 years, what does the world look like when this is all adopted, it's all being used? What's the impact for the individual users? Is it a better place to live, safer place to live? What does it look like for the citizens of the world?
Yeah, the big vision side of things. There are an incredible number of exciting technologies that exist and are starting to come online between, autonomy, robotics, AI, all these different things. But what's also true about a lot of these technologies, especially the hardware-based ones, is that they're kind of luxury toys today. And it's part of our, excitement is not necessarily enabling an autonomous car to drive around downtown San Francisco, for example. Okay, that is neat and sure, that's interesting. But what I'm much more interested in is how do you get the autonomous ambulance to go drive through the snowstorm when a human can't? Or, I grew up way up north in Michigan where it's snow all the time. How do you start to get vehicles to operate in environments where humans can't operate or won't operate, or it's unsafe for them to operate? Or how do you take the benefits of precision agriculture, which the benefits of precision agriculture are just staggering, that the amount of water savings and fertilizer savings and fuel savings, but the problem is only large farms can typically afford it. So how do you take these benefits that large farms can afford and bring those benefits into developing countries, into areas where water shortages and labor shortages and these things are really crippling? And how do you take all these technologies that are being developed and help them reach their scale? And that's really where we shine as, like I said, the superpower of space is scalability. So, we're big fans of these technologies and the believers in the big positive impacts that they can make in the world, not just from the sustainability aspects, but just getting these technologies out to the people that need them and where they can make the most impact and generally improve human life. But in order to do that, they've got to be scalable and they've got to be affordable. And the foundational layer for so many technologies today is just for these technologies to work, they need to know where they are. And that's what we can provide, is just bringing that structure to the world and hopefully opening up, taking things that are, again, for lack of a better term and not to be insulting, luxury toys, and making them just commonplace, affordable things that are part of everyday life around the world.
What are you doing right now, or what do you have in the works that you're really excited about? Maybe anything that you can share that's, maybe coming out in the next 3 to 6 months or just anytime this year. What are you excited about? What are you fired up about?
Yeah. So, the team has been working day and night here for quite a while, and our first production class satellite just passed all of its big testing. So it is on track to be launching in June of this year on the SpaceX mission. That's something that we're super excited about, to get that one up there, because that's really going to start to open up the floodgates on being able to test and demonstrate the capabilities that we have with all of these different customers and partners around the world, and show them not just on the ground. We launched our demonstration satellite a couple of years ago and proved the core tech work, but this is the first time that we'll actually be able to provide commercial high performance satellite navigation capability from space directly to customers. It's kind of a intermittent beta level capability, but this is really going to be the first of an entirely new world, for the entire navigation community, and hopefully for all the, the technologies that navigation supports, to see what's possible with these new type of services that we're able to provide.
What about naysayers? Are there any people that are out there who you'll hear about your approach, how you're doing things, and just say, no, that's impossible, it'll never work?
Yeah, we've been hearing that since the beginning, and I'm sure we'll continue to. I mean, generally, the people that we hear saying it won't work, when we show them test results that it's working, they're a little quieter. And so, I'm not so arrogant to say that we won't have any sort of go backs, or that we've solved every single problem that's in our way that's ahead of us. But all of the big ones, I think at this point, the team that we have here is the world's leading experts in how to do this. And we've gotten pretty good at what we're doing. So yeah, I'm sure there's going to be hiccups along the way, but so far we've gotten pretty good at proving people wrong on a few things too here. So yeah, not overly concerned on that. It's been an interesting road building a startup, and there's always challenges, whether it comes on the business side or on the funding side or on the technical side, but it's part of the ride. And like I said, you solve one problem, then you solve the next. And if you solve enough of them, then you're successful.
As I touched on earlier in the interview, it does seem like there's just a lot more space technology startups that are being funded. I think there's a lot of interest and excitement in this space. What advice do you have for founders who are not yet in the space, but are interested, passionate, and do want to start building? Any advice that you could have to share for them?
Yeah, there's a couple of pieces. I mean, one, for people that are just looking to get into the space world, even if it's just, not necessarily as a founder, just as an engineer or anything else, or a business person, is that don't be afraid of space tech. In the space world, the same as the automotive world, the same as the computer world or anything else. I mean, every wire has two ends, every bolt turns left and right. You're turning them with the same wrenches. That it's not that different. Like aluminum is aluminum is aluminum, steel is steel is steel, copper is copper is copper. Like we're building on the same physics, the same principles as other industries. Certainly there's different requirements, different levels of safety, different testing and things that you need to know in the space world. That's all learnable. And so don't be afraid of the space tech world. That's something we've seen before, of thinking like, oh yeah, space, it's all this really hard stuff. It's when you break it back down to physics and first principles, it's all, the world's built on the same physics, no matter what you're building. On the founder side of things, I mean, this is, again, kind of more generic advice for founders in general, is kind of the same thing I mentioned earlier, is you can't start a company behind a computer screen, at least, especially not in the hardware business, maybe in the AI business or something, but get out and talk to the customers. It is so enlightening, and there's so many things that you will learn that you just never thought of when you actually get out. And when I say get out and talk to customers, like Zoom calls is one thing, but actually going out and having FaceTime and seeing the applications that you're supporting and talking to the farmers or the construction workers or the people that are on the front lines actually using this equipment out in the field, it is so incredible just to see how many parts that, you'll never think of building spreadsheets. And that's something that we learned early on, but continued to urge our team is like, go out and talk to them. And that's where you learn what the real problems that exist are.
Makes perfect sense. I love it. All right. We are up on time, so we're going to wrap here. If there's any founders or engineers or investors, anyone listening in that just wants to follow along with you in this amazing journey, where should we send them?
Yeah, LinkedIn's are probably the best place to connect with us or connect with me or the team. Otherwise, if you meander on over to our website, it's xonaspace.com, where I was watching that and where I was looking for good people to join an exciting team and mission and what we're doing here too.
Amazing. Brian, thanks so much for taking the time. It's been a lot of fun.
Awesome. Thanks, Brett. Appreciate the opportunity to be here.
This episode of Category Visionaries is brought to you by Frontlines Media, Silicon Valley's leading podcast production studio. If you're a B2B founder looking for help launching and growing your own podcast, visit frontlines.io/podcast. And for the latest episode, search for Category Visionaries on your podcast platform of choice. Thanks for listening, and we'll catch you on the next episode.